Okay, what's up, dudes? Today is Friday, the 18th. It's 1:08. And what we're gonna do is some code. We're gonna do some programming. Let's see where we left off yesterday. So we reorganized things to do, bugs debug, after we did some play testing to verify that we did fix the bugs that we tackled, and also that the other minor changes that we made to associated logic didn't create any new bugs. And it looks like they didn't create any new bugs, and we did get rid of them, so everything is good yesterday. Today hopefully will be another repeat of that, and we're going to now go to things to do and look at our next task. Our current issue number 1 that we had organized yesterday as the top spot is, does click card active need a lock? Check this. And all we have to do to determine that is, first, always check for updates to our extensions. I'm gonna have to restart them because they would be disabled in that case, and we might expect them to not be disabled, but they would be, and then we're not gonna be able to do autocomplete and all that cool stuff. But they were good today, so let's look for click card active. Control Shift F. We're going to find the verified must transfer verified race condition prone. So that means we do have a lock for it, right? Yeah, we do. Okay. And the lock, so the lock, I just was kind of lost in the sauce, you know? I was lost in the sauce when I was wondering about this, and okay. So, but what I do notice is, okay, see, so this is where I realized I made a mistake in my thinking yesterday. So I was concerned about the location of our locks, right? And this is why we have to go slow and make sure any change that we make is like correct. As they say, direction matters much more than speed, and I think that is true. I have learned that there's a time to go fast. Now it's not that time. It's the time to be careful and to just make sure that we're not making any mistakes. So I was noticing that we really only need the lock. I was noticing that we need the lock on the internal value alterations. Which just made me realize I have to add another check. Verif, because I think some places we set value for a attribute. Ooh, I don't know if I could find that. There's no way I would go through all the underscores. There's no. I would just have to go through all the internal use properties. See, so this is how sidetracking happens. This is programming. So I have to keep track where I was. we need to verify that internal use adders are locked outside of setters getters. So review all internal use adders, i.e. underscore x to verify we aren't modifying them outside of getters and setters, modifying or accessing, since race condition prone instances of these need to be locked. Yeah. Alright, so we'll just go through each file and find the internal use adders and review them. Yeah. So back to where we were, and we're talking about how we had flawed thinking. We were saying that we would need the lock like for this, so I was like, oh well, I really should put the lock here. We don't have the lock here, but well, we do have the lock. The lock gets utilized right here. But you know, I'm wondering, should we actually use the lock like at the beginning of the setter? Because well, no, we don't need it right there, because all this, well, technically, well, this would be when it's being defined. Well, yeah, but it gets defined every time. That's the problem. You know, I'm noticing noticing that we could probably improve this by to a large degree by, for one, not defining the function inside of the setter every time, and then two, by having one core function defined that is used in various places, to where we would just define it once and like we could put this inside of the change attribute list file and import it, because currently this is just not optimized. There's a bunch of places. Let's check this out. So if you do Control Shift F for def core func, look at this. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 6, 7, 8, 9, 10, 11, 12, 13, 14, 14, 13 results. It tells me right there. 13 results. That is a lot. Like, we could just have one. We could just have one. Let's see what they all have in common. What's this? What's the? How do you open? Here we go. Open an editor. So I can open this in the editor. Yeah, look, and it's gonna show me. Whoa, it doesn't show me the whole thing though. Oh yeah, it only shows me the line. But I mean this. It shows the first two lines for whatever reason. I wonder if there's settings to this. Anyway. So they all take self, item, or val, except for this one, because that's for clear. But and then it changed from dir check. Yeah, so first of all, we so this could be called like the transfer. We could create a little function that's called the transfer or not function, wherein we would run these first few lines here that say if type of val is equal to tuple, val equals val 0, data, and then data transfer function, because that always gets a run in these. We check to see like this: if type val is equal to tuple, type val is equal to tuple, val equals val 0, and then otherwise but we would have to add in some code. Like we would have to pass the arguments I'm just sitting here, I'm thinking about this. I don't know if I really would want to do this. Like, I could just leave it as it is. So we have the core function. It would have to take more arguments, right? Like if we made one of them, because then when we call data transfer function, like how would we know which, you know, of these to pass to it? And we also have to consider, like, I think first of all, what I'm noticing is the placement of the lock is not actually perfect. Yeah. So I'm not so much. Let's just do one thing at a time here. And the more important thing that like is bugged technically with this is the fact that we have the lock acquisition down here. And then see, we also have the lock here. So choose multiple cards. We had to change choose multiple cards to be a re-entrant lock. One of them had to be changed to an R lock. A re-entrant lock. Which one was that? Choose multiple cards. Yeah, so that one does have to be a R lock, but this right here, see how we acquire the lock on this line, and then we run core func, and then inside of core func we acquire the lock again. That's actually not correct. Like, that's bad code. We already have the lock acquired. And so the overall idea here that I'm getting at is we need to make sure that we're actually locking not just this line, which modifies the internal use, but we really want to lock the entire process, because we don't want, let's say we're in the setter here, so we're in choose multiple cards setter. Let's say we're running this setter, okay? We went to set the value, we're in the middle of setting the value, and let's just say we're at a certain spot, you know, like we're right here, okay? We got down to this line or whatever, core func, we're running core function, and then we're like right here. Well, let's say at this point, we then go and access the getter on one of the client threads, because it is race condition prone, it is handled multi-threaded. So if the other thread goes to access the getter, it's gonna also access this like right before the setter is setting it. So even though the setter happened first, the getter will finish first, because it's only one line of code. It's going to be faster, and it's going to return a false value or whatever. It's going to return the wrong value. Or if they're running the setter in the thread and then they're running the setter here, if we don't use a lock at the very beginning, you know, it could be a race condition issue where one thread just happens to finish before the one that actually started, and then you get swapped values. You get the ladder change being applied first, and then the earlier change being applied last, so then you have flawed data. The values are not correct. So that means we have to lock this entire process. We don't want the setter, we don't want another setter to be able to be run at all until this one finishes. So we have, like, do we really need the lock though? Right here. Well, we do need the lock before we define the function, because the function handles the actual race condition prone attribute right here. This right here. So this has to be locked. But if we put the lock right here, that means whenever we put the lock also right here for the entire function, because we want the entire function protected, you're gonna have double lock acquisition, which is weird. can do it with a reentrant lock, but like in this case, it would just be weird code. It would be bad code. It's not the proper way to use a reentrant lock. So, do we really need to have the whole process locked? Change from dirt check rule equals false. Then we call the data transfer function. And then we have the game object equals the self. Well, doesn't this also mean that the game object would be race condition prone? Like the actual game object? I'll put a note here, because that's just another thing I noticed. Yeah, getting rid of all race conditions is actually pretty hard. You have to really like be on your P's and Q's to accomplish that without making mistakes, forgetting certain objects. And we'll check for shared objects among non-adders, and I'll put don't forget class instance objects such as P1 game and also also don't forget when these objects are accessed via self, because like that still would be yeah, that would be a race condition issue. So there's a lot of things to consider here. One of them also that we need to consider is the like, and we went through this before a little bit, I think, but the question of whether or not should we lock an entire instance object whenever we're accessing a race condition prone attribute, a shared attribute, or could we just lock off the attribute? And I think as long as it's kind of hard for me to understand. This is a little bit of a recursive idea. Like you have the game object, the class instance, which has a bunch of attributes. Those attributes are shared, so you have to lock them. But what about whenever the attribute, the shared attribute, accesses the actual self, like the game object? Because wouldn't that imply that you were accessing a shared object without a lock? Like so in this case, this is a shared attribute, we have a lock for it, but also we have a call to the self here, which is the overarching game object. And this is also a shared object, because if this setter or getter is being run on the other thread, it's also going to access the self. And I suppose this depends. Like, it depends on whether or not the game object is gonna be like modified, or if it's gonna rely on data that's prone to a race condition. You know what I mean? Like, if we're just using the self to, let's go to data transfer function. If we're only using the self for like in a specific way, that doesn't necessarily mean we have to lock it. Like, if the data is not prone to a race condition associated with it, we don't need to lock it. So what do we use the game object for here? If we don't make any modifications to it, we should be safe in these instances. But if game object is not equal to none, it will set the attribute of the associated timestamp. But that's for the associated attribute, which would be like, this whole process would be locked via the attribute lock. So this usage of the game object itself would not result in a race condition. So yeah, I'm pretty sure we would be safe with this, meaning we wouldn't, this is a thread safe operation. The attribute lock would take care of the data integrity here. Now, if we accessed a different attributes, you know, whatever, like data, then we would have an issue. But in that case, we could just use that attributes lock, granted that it did have a lock, you know what I'm saying? So at least in these instances, I think when we call change attribute list from setters and stuff, and we pass in the game object argument to data transfer func, I don't think we need to lock that per se. Yeah, we wouldn't need a lock here. Verified don't need a lock for the game object self in this instance. It only handles this attribute. so the adder lock is sufficient. Which is already being acquired at this point. So we have to actually, I'll add this as well. Ensure proper lock spot implementation. Ensure places in setters, getters that utilize a lock have them acquired at the correct location. I.e., if we need to protect the entire setter, make sure the lock is prior or at the very beginning of the setter. I gotta use the restroom, I'll be right back. Alright. So I'm not worried about the core function thing right now, but eventually we'll put this in non-pressing issues. Core func conversion. Yeah, that is definitely not optimized code. And also, we can convert it to a single function that is used in various places. That I'm not so sure about, but we'll put it anyway. Core func conversion. Instead of calling core func over and over in each, or rather instead of defining over and over in for each setter, we could define it in one place, perhaps changed attribute list by, and utilize it but this would require some thought, require additional params, etc. Have to be very careful and test often before and after any changes. True. Alright. So click card active does have a lock. Lock internal use adders for properties. View logic associated with this. Unsure. Lock internal use adder for properties. Aren't these always actually an issue? Wait, but didn't I put this? Where did I didn't write this down. Lock internal use adders. Thought I put. Anyway, I guess I didn't. Review logic associated with this. Unsure if it's actually an issue. This should actually be rephrased to ensure. I'm quite certain I wrote this down. Like, where did I write it? Pressing issues? There we go, yeah. Review all the internal use adders. Alright. Yeah, verify that internal use adders are locked outside of setters and getters. That's actually like gonna go up here. Okay, so let's see, what do we need to do first? Check for shared object among adders. Ensure proper lock spot implementation. So we'll take this one out, put it back in pressing, and we're gonna focus on these two. Ensure proper lock spot implementation and verify internal use adders are locked outside of setters and getters. So yeah, I guess we'll, since we're like already, my mind is already in this spot of ensuring the proper lock spot implementation, we'll focus on that. And game. Alright. So yeah, we need to look at all of the locks and just make sure that they're at the right spot, because currently they're not. We wouldn't need the lock well, we wouldn't need the lock there at all because we already used the lock here, but we should probably use the lock at the very beginning of the function. So this right here is duplicate. This is already being handled. Like, we don't need to check SS or CS. We don't need to use the lock. The lock is already being used. We move this assignment to the top in the type val equals to, but this assignment would errantly be to the tuple. Tuple instead of tube 0. I'm confused by this. We move this assignment to the top and the type val is equal to tuple. This assignment would errantly be to the tuple instead of tup 0. Oh, okay, I see. Alright, yeah, I know what I'm saying. Alright, gotcha. This row use form is what ultimately gets used via setter getter. Need to review all of their lock properties. Yeah. So I was slipping here. This is already done, so we can get rid of this. And then we just put that right there. Get rid of this. And let's review the core func. So we have core func, takes out val, type val is equal to tuple, change check bool is equal to true, val equals val 0, else change check bool is equal to false, data transfer function, and then after that we set the internal u of the val, of the adder to val, which is good, I think. Val is equal to true. Regardless clear. Yep. Alright. So now we need to put this code at the top. But how do we do that? How could we put the code at the top before we actually have core function defined? See what I'm saying? Like, we can't put this at the top all we need to do so this is a little bit complicated because we have some like incompatible logic here. So let's just focus on the lock. If we wanted to put the lock up here at the top, because we need to lock when this function gets defined, because it uses this line right here, we need that to be locked. So we would have to have the lock up here, but if we have the lock up here, that means we would need to check if change attribute SS or CS up here. Because we wouldn't use the lock, you know, unless it was set to SS. But then when we call the, well, no, wouldn't that just, that would be fine, right? Yeah, this is fine. We would just take this away. I'm tripping. We just take this away. Have core func get called regardless. And then at the very top, we would check for SS or CS. So if we were to use the with statement, uh, context manager that is, we would have to repeat this code, right? Because we would have to put this in here, and then, because we need it to be locked, and then we would have the else for CS, and in that case, we would have to run this code still, just without the lock, so it would be a lot more lines. You see what I'm saying? It'd be way more lines. And this touches on the idea of moving core function altogether to where it's not assigned in the setter. But like I said, we're gonna go one step at a time here, just really for safety. And we're not gonna try to like do a bunch of things at once. We're just gonna do one thing at a time. And I think that instead of using the with, we would just acquire it manually, which is perfectly fine. With is just a little bit more convenient because it takes care of the releasing of the lock for you. Yeah. Well, and also you have to make sure that when anytime you're releasing a lock, that the place wherein you're releasing it is directly connected to the place that you acquired it. So like, just in case you might have acquired it previously and then you're releasing it, well, I don't know if we would have to worry about that, because if they're not R locks, there wouldn't be recursive lock acquisition, and I'm pretty sure what I was just describing would require recursive lock acquisition. Yeah, if you needed to like verify that the releasing of a lock was associated with the correct acquire, and the concern might be that you would be releasing a different acquisition that was previously made in a different logic section, that would imply that you would have acquired the lock twice, unless the logic that caused the second lock to be acquired was invalid. If the second lock acquisition's logic was no good, you could technically release a lock that had acquired previously, and that would require you to have fucked up pretty badly though, because then you would have that first lock acquisition not being released properly. So then you're just really an asshole if you messed up that bad. But I'm gonna add it anyway just to review this. This is not something that's gonna take long at all, but it is important since we're dealing with locks. Let's just go ahead and make sure everything's good. We'll just say lock release acquire. I think we already did this before, like we already reviewed this. Lock acquire release logic. We just want to triple check it and make sure. Triple check these locations wherein we are manually using with acquiring. And releasing locks. Check these locations to ensure logical security, i.e. that the release would always be connected to the proper acquire, and that the acquire would always be run or be executed prior to a subsequent. And I know that's a little bit complicated, but it's really not. It's like on off, on off, on off type shit. Just making sure that your logic is airtight, and that you're not going to sometimes acquire a lock and not release it when you should have. Should only take me a minute or two to do that. 15 minutes ish. Anyway, back over here. So we're looking at this. If change attribute this is equal to SS, we would then manually acquire the lock instead of using with. Now we need to do. We don't even really need an else, right? Like we just need if it's equal to SS, we acquire the lock. We go all the way like if it's SS, we would acquire the lock. If not, we would acquire the lock. So at this point, all this code would be locked. We would this good stuff. We would define the function and call the function. Then at the very end, we would then say multiple cards. Cards lock. What's it called? Acquired. I think that's what it's called. Let's ask Gemini. Or Gemini. Let's ask Gemini. Python. Oop, is it safe to use anabolic steroids? See, so I get steroid injections, but it's a different type of steroids I found out. I actually thought I was getting injected with anabolic, but it's actually cortical steroids, which is completely different. It actually causes muscle loss, but it greatly reduces inflammation and all that. Anyway, Python choose. What am I doing here? Lock dot acquire. Is that what it is? Lock acquired is a method used to check if a lock is currently acquired by the current thread. Returns a Boolean value, so it returns true if the lock is currently acquired, false otherwise. Gotcha. Alright, yeah, so that is what we want to run. We want to say if self choose multiple cards dot lock dot acquired is equal to true, meaning if the lock was acquired. And honestly, we could either run this or this. It's basically checking like it's the same concept. And this is a little bit more concise or precise in its description of, you know, what's going on here. So only if the lock is acquired, we would then release it. So this would just be release, release. Yep. There we go. Easy. And honestly, yeah, that's nice. I actually like this way better than the with. So we say if it's review, we have choose multiple cards as the setter. If the change attribute list SS or CS is equal to SS for server side operation, then we would do the choose multiple cards lock acquisition, and that is correct. If we're client side, we don't need to acquire the lock. We then define the core function, and then we execute the core function, and then we check finally. Oops, and this is at the wrong. Wait, no, I'm tripping. This is right. I was looking at the wrong thing. Yeah. So this indentation level is what I was looking at. Bam, core definition, and then core func calling. Then the check for choose multiple cards lock acquired equal to true. If the lock was acquired, release it. True. And then we would choose multiple cards lock release. Good deal. Alright. So that one is done. And that's what we need to do for all of the setters. We need to, all the locks that use setters, this is what we have to do. So we're going to do Control Shift F, and we're going to look for all instances of lock, and we're going to find them, and we're going to fix them. So I did go to the gym. My back is messed up, but I tried, I'm trying to see before I go back to work, how it is, because my job is very physical. Like, it is so bad on your back, and since I do have a back injury, I kind of tested the waters, to see how it's feeling with like a light workout. And I did like a moderate. I didn't do lifting. I didn't do like deadlifts or like squats with weights or calf lifts with anything like that. I just did, pretty much no workouts that really involved my back. I think the worst one, the one that bothered it the most, was actually doing like bicycle. I could just call them bicycle sit-ups. It's basically where you lay down and like these kind of crunches, legs in like a bicycle motion, like you're riding a bike. But it kind of does like that lower part of your back. I did notice some pain there, so it's not. I'm still not better, but I'm definitely getting better. It's definitely better than it was, where I couldn't even bend over at all and like pick up a piece of paper. I definitely didn't even feel like I could have went to the gym straight. So I'm actually, I would say I'm like 50-60%, maybe 60% back. That's neither here nor there. Now, let's continue. So clickable card list lock. This is Yeah, and you see all these places like this where I do if SS or CS is SS, and then with the lock execute some code, else execute some code. Honestly, we could just do if SS or CS is SS, acquire the lock, execute some code, and then we don't need an else. We would just then subsequently check if that lock is acquired. In this instance, since it's only one line of executing code, it's like, it's six one way, half a dozen the other. But certain places, it's smarter just to manually acquire it than to use the context manager. Yeah, I was just verifying that we do need this lock here. Because I was thinking, since we always use the lock on any method associated with it, do we still need to lock it when we're accessing the list directly? And I think, yeah, like definitely we would need to lock it. Like if we're gonna lock the modification of it through the methods, I think we should lock accessing that list. I mean, obviously, but I wonder about shit like that because I'm just not that smart and still kind of new at the whole lock thing. So it's it'll make me question, like, is this correct? Is this gonna cause, you know, a deadlock or whatever? And it's not recursive or anything. Yeah, this is not like recursive or anything, so it shouldn't cause any problems per se. Not like per se, it absolutely shouldn't cause any problems. So verified correct logic. Although methods of this list are locked, we still need to lock accessing the actual list. And it's worth it to do little sidetracks, but getting sidetracked too much is not good. And the input text final lock, I'm pretty sure input text final is not a property, so that's why we use the lock outside of the adder, because input text final is it is not circularly it's a string, so it's not a property. Yeah, so let's go back to lock, and we were all the way in, I can't remember exactly where we were. Let's just scroll through. Okay, yeah, we were right here. Verified correct logic. We acquire lock here outside of setter, since this is not a calculated property but a simple str adder. I'm using like old English language, like, but no, just use concise, clear, modern English, bro. So we're gonna rename this to be reentrant lock. Because it is now a reentrant lock, and I want to make sure we know that whenever we touch it, whenever we look at it, whenever we breathe it in, I want to know that it is a reentrant lock and not a regular lock, because that is an important distinction. Choose multiple cards, lock. down to game, which is where we were. And specifically, we were. Oh, wait. Yeah, we had went through those. We went through client. We went through deck. Custom time list. Then deck. Then we're in game. Yeah, that's where we stopped right there. Alright, here we go. So this is where we need to start. And I'm going to take my little break. That's 2:24. I'll be back in a few minutes. And we'll modify this to get our locks right. Alright, so we're done with that. Yeah, so that was cool. It took a while, way longer than what I wanted to. Um, but we did it, and I'm gonna go ahead and stop for a while. I'm gonna go eat. I think I'm a little hungry, and come back. We'll do a couple more hours, I think. Yeah, so I'll see you guys in a bit.